export to the cloud. Okay, hello everyone. My name is Saul Nassisi, and I'm with Chain Letter Labs. We're a company that works to create verifiable credentials. And today's topic is digital credentials in the AI age. And so I'm hoping you'll come out of this with some sense of how digital credentials and AI are going to interact, what some of the dangers are of AI to digital credentials, what some of the opportunities are. I'm going to talk a little bit about the different types of platforms that can produce digital credentials and the pros and cons of each platform in regards to AI. And so you'll have a shallow technological basis with which to make decisions and think about a platform that you might have or a platform that you might want to purchase in the future. So I want to start off by asking you to take a look at these two credentials and tell me which one is real, which one was issued by an institution, and which one was created by AI. And it's actually a trick question because both of them were created by AI. The one on the left is a alteration of an actual credential. So the University of Texas, when they issued my diploma, this is pretty much what it looked like, but it was not issued to John Rogers Smith. It was issued to me, Saul Nassisi. And so I put it into AI and I had AI change the name. And so that shows that one way that AI can create fake credentials is by taking a real credential and just modifying it. And it's very easy to do that. The second credential, which in some ways, to me at least, looks actually more official, was totally created by AI. And so this is the prompt that I used. It took me about 30 seconds to do it. I have lost my MBA diploma from the University of Texas at Austin. Can you generate a diploma replica for me for the graduate year of 1997? Please use the name Jane Smith. Make it as close to original as possible. And AI, within a minute, spit this credential out. It looks pretty good. University of Texas at Austin. It has the seal, and it has sort of an embossed seal down at the bottom. Now, why is this important? I'm going to tell you a little story that I think, to me at least, encapsulates why the ability to create fake credentials is going to become a problem in the future. So I was going to get a car with my son. My son had just graduated from college and he had his first job. He needed to drive to his job, and so he needed a car. And so we went to the dealership and selected the car, and then we went to the loan officer to talk about getting a loan for the car. And we went through the loan process, and as the loan officer is talking to us and thinking about the rate, he asks if my son has graduated from college. My son said yes, he had. The loan officer said, well, can you show your diploma or provide us with your diploma? Now, my son didn't have it on him. He went home and then later the next day brought it back. But this kind of highlighted to me that my son, if he hadn't graduated from college, it would have been very easy for him to say, yes, I did graduate from college, could have gone home, asked ChatGPT to go ahead and create a diploma just like I did here, printed one out, and here's a printed version of that diploma, brought it to the loan officer, and the loan officer, I'm sure, is not trained to detect an actual diploma from a fraudulent one, and so would have checked off, yes, this person did graduate from college and is eligible for a lower rate. Now, my son never would have done that, but there are people out there who might not be as scrupulous. And so I think in the future, what's going to happen is loan officers and other people who need to verify these credentials are going to be hit with a deluge of fake information. And they're not going to be able to rely on the paper that the credential is written on. They're going to need to call the university. They're going to need other ways of verifying it's true. So if you're a registrar, what you're potentially looking at is a tidal wave of verification information coming at you. And people are going to want to know, is this paper actually real? Because they can no longer trust it, because AI makes it so easy to create fake, fraudulent ones that really look good and real and that can pass a manual verification check. So on the left, that's what we're talking about. We're talking about forgery at the speed of software, being able to pump out very credible looking diplomas, transcripts, badges, you name it. AI is primed and ready to do that. But the good news is AI is also a potential solution to this problem because AI and agents, which are increasingly going to become part of our future, can automate the whole verification process. And so imagine something like this. My son goes to talk to the loan officer about the loan. The loan officer takes his information down, types it into the system. The system then sends an agent out to retrieve the credential, which either sits on my son's LinkedIn account or perhaps even at the university that he graduated from, is able to automatically verify that the credential is valid, comes back to the loan officer system, puts check, yes, this credential is valid, and the transaction is able to proceed. That, I think, is the kind of future we're looking at. And in that future, having a credential that can be easily verified is super important for the whole system to work. So to get to that point, it's really kind of important to understand the underlying technology. And I'm not going to spend a lot of time on this, but I want to give you just a little bit of information about how the different credential systems work and how a digital credential actually operates across these systems. And I think once you have that, you're going to be much more empowered to be able to make decisions no matter which platform you go with, and you'll be able to optimize the way that you configure the platform with your vendor. There's some key sort of decisions that you can make that have a technological kind of bent to them that can really make your system much more durable. So the first type of platform that exists out there for creating digital credentials is what's called a hosted platform. And if you're creating digital credentials today, you're probably using a hosted platform. And the way a hosted platform works is that someone gets a digital credential like this. Usually it's a PDF, and the PDF has a number across it, 1, 2, 3, 4, 5. And when that credential is given to someone else, they take a look at it. They are directed to a website where they would type in 1, 2, 3, 4, 5, the number on the credential, and that number would then be checked against a centralized database that the vendor maintains. And if the number matches, it responds back with information about that credential, the name of the credential recipient, the school they graduated from, the degree they received, the year they graduated, that type of sort of basic information. So the good thing about that system is it's up and running, it's easy to use, it's relatively inexpensive. The downside to a system like that is that all the information is stored in a centralized database that's managed by one vendor. And so what happens if that vendor goes bankrupt? The average Fortune 500 company lasts 10 to 15 years. And so you're entrusting that a company, most likely not even in the Fortune 500, is going to have a lifespan beyond that. And when you give a diploma to someone, a digital credential, the idea is that they have that credential for life. If that database goes away, okay, if that vendor goes bankrupt, if they get purchased, if they change their business strategy, the credentials that you've provided go poof because they can no longer be verified. The veracity of the credential, the ability of the credential to be used depends on that centralized database. The other problem with a centralized database is that it is a big, juicy hacking target. So we've all read about how banks, credit card companies, health companies, the government have been hacked and information has been taken from them. So this presents a juicy target for hackers to basically get access to. And if they do, then they have the means of verifying fraudulent credentials. They can manipulate, they can basically render that database unusable. So the industry understands that there is a problem with hosted platforms. And as a result, it got together and it formed a new mechanism, a new way, a new standard, a new open standard called WC3VC in order to create a pathway for the future of credentials. And the first implementation of WC3, because WC3 is just the standard, So it basically lists out the way that these future credentials could work, but you need an implementation of that to make it real. And Open Badges 3.0 is the first implementation. So I'm going to talk about WC3 and Open Badges kind of as the same thing. And the way WC3 and Open Badges work is that instead of the verification happening with a centralized database, it happens on the credential itself. The credential contains the verification information. And I'm going to talk a little bit more about that later on. But the advantage is you don't need to rely on a centralized database. If the centralized database goes down, no problem, because it's not needed. Okay. The downside of a WC3 credential is while you don't need a centralized database, you need something called a public key, and that becomes its vulnerability. The other thing is that other than Open Badges 3.0, WC3 is a standard, but it hasn't been widely deployed or supported. So it's kind of nascent, it's emerging, and it's not clear exactly which direction it's going to go in. The third way that credentials can be verified, and another one of the sort of futuristic, future-proof concepts, is using the blockchain. And so the concept is it's similar in some ways to a hosted credential in that you have your credential and it's verified, but it's not verified against a centralized database. It's verified against the blockchain. The blockchain stores the verification. And the blockchain is this system which now helps to pass trillions of dollars of cryptocurrency, of money. It's used by banks. It's used by the Defense Department. It's a proven, robust technology. And so you're able to access this very proven, robust technology in order to verify your credential. You're not relying on one small company and their database, which might go away. So that's the high-level overview. What I want to do is actually dive a little deeper into WC3 and blockchain and give you a little bit more information on the technology, because I think that that will really make all of this real and help in the decision-making process. And so I have some props with me which get a little bit hazed out by my background, but I'm going to do the best I can here. So let's say that you are a university registrar and you're issuing a credential. And here is a diploma from the University of Texas at Austin. It's the same one that we saw on the first slide. Okay, and you now issue it to Jane Smith. Jane Smith receives it. When that diploma is issued, and now we're talking about WC3 and Open Badges, that diploma is issued with a packet, okay? And that packet is represented by this envelope, okay? And inside the envelope, okay, is a numeric representation of this diploma called a hash. And a hash is basically a mathematical way of taking a file and rendering it as a number. Okay, and this is not a real hash. I just made this number up for illustrative purposes. But let's say that this document, when it goes through the mathematical process, is rendered as 045 ending in 31. Okay. If anything in this credential is changed, one pixel, one letter, one tiny dot, the number, the hash, changes also. All right, so when the credential is issued by the registrar, all right, it's hashed, it's created into a number, and that hash right here is put into the envelope, all right? And I'm going to do my best to show that process without blowing up the screen. Put into the envelope. Okay, there it goes. And then the envelope is sealed, so that not anybody can access it. It's sealed using the university's private key. So the university is given a key. So think about there being a lock here, and the university is given a key to lock the envelope. And then it is all attached to the diploma. Okay, so you have the diploma and you have the hash, which is inside a locked envelope. Now, let's say that I'm my son and I'm going to get a car loan, and I want to provide it to the loan officer. So I provide the credential as well as the envelope that goes along with it, the packet that goes along with it with the verification to the loan officer. So what the loan officer does, he doesn't do this, but the software would do it that he'd have installed in his computer, is it takes the credential, okay, it then hashes it into a number, all right? So you've got this hash now, it then he then or she uses a public key that she receives, and usually the public key comes from the vendor software that the loan officer has installed on their computer to read these credentials, but takes a public key, unlocks the envelope that, remember, was locked by the private key, okay, removes the number that we put in there. And remember, the number ends in sorry, upside down, and 3-1, and compares it to the hash that they just created, okay, from the credential that they received. So to recap, loan officer receives the credential, makes a hash of it, opens the envelope with the public key, the packet with the public key, takes out the number, the hash that was created when the credential was first created by the registrar, compares the two. If the two match, okay, if they both end in 3-1 and all the numbers are exactly the same, then you have a credential that you can prove didn't change. Because if the credential had changed, the hash would change. So instead of 3-1, you'd have 3-2 when you're hashing that credential that the loan officer received, and you have a mismatch. Numbers don't match, and therefore there was a change to the credential, and it's been changed in some way, whether accidentally or intentionally been tampered with. So that is represented by the information on the left. Okay, so you can see institution generates credential. The proof is inside the envelope. In order to unlock the envelope, you need a public key. You then get both versions of the hash. You compare them. Boom. You can determine if the credential is real or not. That is WC3. That is open badges. Blockchain works a little bit differently. Some similar concepts, though. So you are a registrar. You create a credential. You then take this credential, you hash it, you turn it into a number. Okay, here's the number. The number is then sent to the blockchain, okay, up there in the cloud, blockchain cloud, and it's stored there. And once it's in the blockchain, it can't be tampered with, it can't be changed, it's there forever. It's what's called immutable. Now, my son walks into the dealership, talks to the loan officer, gives him the credential. The loan officer then takes the credential, hashes it using the software, okay, and compares it to what is up on the blockchain. So you got blockchain 3-1, you've got the credential that he's just received and hashed 3-1. They both match. The credential has not been modified, not been changed. Check, it's okay. So it's a much simpler process. There's no packet, no envelope. There's no private key to seal it. There's no public key that needs to open it. It's just the credential itself and the hash, and storing the hash on the blockchain. All right, so that's kind of an important process to understand for both WC3 and for blockchain. And the most important part of the process, the thing that's kind of key for you, is the public key. The fact that the WC3 credential requires a public key to be opened. And without that public key, you can't open the packet, you can't verify the credential, and therefore it becomes unverifiable. So why is this important in the AI age? So think about the example that we said before where my son walks in, and in the future, an agent basically will take the information, will go out, will find the credential somewhere on the internet, and will automatically verify it. So if you're verifying a WC3 credential, you have 5 different steps and 3 different failure points, right? Think about how much more complex that process was when I described it. If you're doing a blockchain credential, you basically have 3 steps, okay, with 0 failure points, because instead of relying on proprietary infrastructure in order to do it, all of the verification happens through the blockchain, which once again is a public utility maintained by millions of nodes. It's a decentralized system. And so you're relying on this decentralized system, which once again supports trillions of dollars of transactions today for reliability. So there's no key fetch, there's no DID resolution, and I'm going to talk a little bit about DID resolution, and there's no external dependency. DID resolution just means that when you need to get the public key, something needs to tell you where that public key is, where you can find it, and it's the DID that does that. And usually that's stored on your institution servers, or it's stored with your vendor's servers. But it's another potential failure point, because if the DID disappears, then you don't know where the public key is and you can't unlock the credential. So there are all of these different potential failure points with WC3 that an institution needs to be aware of. The one key thing, if you do decide to go WC3, is make sure that the DID and the public key are with your institution, that you control them. Because if the vendor controls the DID and the public key, you've lost control of your credential. It basically goes back to almost a hosted solution in terms of dependency. You're dependent on them. If they don't give it to you and they go out of business, or if you decide you no longer want to use them, you no longer want to pay, you're out of luck. And so that is a way for vendors to lock themselves in. So in any contract that you write, make sure that you are the holder of those 2 things, the DID and the public key. With blockchain, you don't have that concern because the hash is stored on the blockchain. So you don't need any particular company. You don't need to rely on anyone in order to get that hash in the future. Now, there'll be providers who will make it easier for you to do that and will automate the process. And that's one of the things that Chainletter does. But you can go ahead and do it manually if you want to, or you can get another provider that will do it. And if the issuer of a blockchain credential goes out of business, you're not reliant on that. That does not harm your ability to verify those credentials in the future. So I hope that gives you a little bit of a technological basis to understand how these different technologies work and to compare them a little bit and to think about, depending on which one you choose, how to best structure it for your organization. So I wanted to also quickly go through 6 different criteria that you should think about when you're thinking about digital credentials and AI. And I compared them against the 3 different solutions to give you a little bit of a sense about how these solutions play. So the first is forgery resistant. How easy is it to forge a document? With a hosted solution, it's relatively easy because there is no hashing of the document. And so I could take this credential and I could change the color, I could change what's on here, I could add things, and the system would never know it. It would only be able to determine some of the limited information that it's stored in the centralized database, but I could manipulate that and get around it by changing the look and shape of this. With both WC3 and blockchain, because it hashes the document, because it cryptographically secures the document, you can't change a thing without that being noticed and the document not verifying, or the credential not verifying. Is it structured and parsable? Can agents, AI agents, extract information from it? You can do it a bit with hosted, but much better with WC3 and blockchain, which are at essence machine readable code. Can you scale verification? So going back to the previous slide, how easy is the process of verifying? And do you need to log in? Do you need to access proprietary systems? Can these systems handle millions and billions of queries? On the hosted side, once again, you're relying on one centralized database that has to be able to handle all that volume. WC3, you're relying on access to public keys and DIDs and making sure that they're available all the time. With the blockchain, you're just relying on this centralized resource that, once again, already has billions of transactions happening. Verification independence. Can you verify the credential without relying on any vendor or partner? Hosted, you can't. WC3, once again, you need that public key. Blockchain, you don't need to rely on anyone. Once it's in the blockchain, you can go ahead and verify it independent of any organization. Long-term durability. We talked about this a little bit with hosted. If the hosted company goes out of business, if its database is hacked, if it has a problem, your credentials will not verify. WC3 is a better, but you still are reliant on DIDs. You're still reliant on public keys. Blockchain, no concern. The blockchain will continue on and you'll be able to access your credentials or your hashes for verification. And lastly, privacy posture. How able is the credential to provide only the information that the recipient wants and needs? Hosted is not great at that. Basically, once you put your number into the database, it spits out everything. Both WC3 and blockchain use what are called zero-knowledge proofs, and those proofs allow you to control the information and verify the credential without providing any personal information. So here are 5 questions that you can ask your vendor or ask yourself to test whether the platform is ready for AI and whether the platform is future-proof for AI. And so I encourage you to do this. This is a good exercise, and I think it will help you, help you determine which solution is best for you. So first, who owns the ability to verify your credentials? Is it your institution or your vendor? And as we discussed with WC3, if you go that approach, make sure that you control the DID and the public key. If it's blockchain, you don't need to worry about it. If it's a hosted solution, then forget it. You're at the mercy of your vendor. 2, could an AI produce a credential that would pass your verification process? And so once again, that goes back to that original question that I asked about the 2 diplomas. With a hosted solution, I could pretty much trick out that system. But with a WC3 or blockchain system, I wouldn't be able to because of the hashing. Can your verification infrastructure handle millions of automated checks, and who pays for each one? So when we think about AI and verification and where this is all going, someone has to pay for that verification. It's going to take AI tokens to do it. And so the question is, who will pay for that? Will it be the recipient? Will it be the loan officer company or the software that they're using? And if so, they're not going to want to pay more money. They're going to want the simplest, easiest process. Or is it going to be the institution that has to pay every time one of their credentials that they've issued is verified? And if that's the case, you also want to have the easiest, least expensive infrastructure. And can the infrastructure handle the scale that's coming to it, which is doubtful or in question with a hosted solution? And even with the WC3 solutions, you need to have infrastructure that can provide the public key and the DID and can do it on a consistent basis and not go down. So if a graduate shares their credential with an AI hiring tool in 2035, will it verify? And this is really about the durability of the credential, something that we talked about. Will a hosted solution still be there? Will the public key be available? With blockchain, we think that this question is a definitive yes. Can an AI agent tell not just that a credential is valid, but what it actually means? And so does the credential have the ability to store contextual information, information beyond just what's on the credential? And so that's something that you might want to think about as AI agents become smarter. So lastly, I want to talk a little bit about the maturity ladder and where organizations are and sort of what organizations can think about when they think about digital credentials and implementing a long-term solution. So many are in the L1 category today, where they're just issuing paper and PDFs. And as we've talked about, those are the least secure and the least verifiable. And those are the ones that will be really problematic going into the future as AI scales up and as more people start to use them to create fake credentials. Hosted digital, as I said, if you're issuing digital credentials nowadays, probably most of you are using hosted digital. And as we talked about, that has its own set of problems. Mainly, you're tying yourself, you're doing vendor lock-in and tying yourself to a fragile infrastructure. And it's a fragile infrastructure for a credential that needs to last a lifetime. So we think that's problematic. L3 is really WC3. These are cryptographically signed credentials. One of the things that people don't think about with WC3 credentials is that the user must have a digital wallet to store these credentials. That's part of the spec. And so is society ready to use digital wallets? They haven't really caught on in the past, but it's kind of something that I think we're going to have to look at and see how that progresses. And then the last, L4, which we think is where things are going to end up, are independently anchored blockchain credentials that are simple to use, fast to verify, will stand the test of time, are durable, and are inexpensive to issue and to verify. So I hope that that gives you a little bit more insight into the digital credential space and also how it's going to interact with AI in the future, some of the opportunities, some of the risks that are out there. Once again, I'm from Chain Letter Labs. I'm more than happy to discuss digital credentials more with you. You can find me on LinkedIn. It's Sol, S-O-L, Nasisi, N-A-S-I-S-I. Happy to answer any questions you might have. We'll be doing more of these webinars in the future, so look forward to seeing you at them. Thanks very much. Have a nice day.